Okay, we've got 3 tests in our test suite, and now I'd like to show you a feature called code coverage. Before I talk about what it is, let me just run the test suite with the code coverage option. You get to this feature through the test runner window, go to the test runner, and then you'll right-click on one of the nodes in your test suite. In this case, I'm going to right-click on the top level of the test suite. And one of the options in the menu is Run Test with Coverage. I'll choose that option, run the test suite with code coverage, and at the end, I get this new test coverage result window. All the tests pass, and the coverage window is showing 100%. So what does that mean? What is this coverage thing? Coverage is short for code coverage. When we ran the test with coverage, it not only ran the tests, but it monitored which lines of our code got executed. 100% code coverage means that we ran or exercised every line of code in our application. Thinking about our system under test, the calculator class, it means that there isn't any code in the calculator that doesn't get run as part of our test suite. This doesn't guarantee that our code is working, but it definitely improves the likelihood that it's working. At a minimum, it tells us that our code is well tested. So let's play with the code coverage thing some more as we add some more functionality. I'm going to take the multiply test code and copy it and create a test for divide. Value 1 will be 6, value 2 will be 3, and our expected result will be 2. Then I'll create the implementation. Come over to the calculator class and create a method called divide. Just like everything else, it takes value 1 and value 2 as parameters and returns an integer result. That's the structure of the method. Next, the implementation. And this method is going to be a little different than the rest of them because of the divide by 0 problem. You can't divide by 0. So this method will check the value 2 parameter, and if it's 0, I'll throw a new argument out of range exception. And then finally, the divide math implementation. Return value 1 divided by value 2. Go over to the Test Explorer, click the refresh button. That'll compile our code and reload the list of tests. And then click Run All Tests. And as expected, all the tests pass. Next, let's check on our code coverage by rerunning the test suite using coverage. Right-click on the test suite, choose Run Test with Coverage. The tests run and we get the test coverage window, but this time, well, we don't have 100% coverage. Instead, we've got only 86% code coverage on the calculator class. Now, lots of teams would be perfectly happy with 86% coverage. I mean, that's a very good number. But for the sake of this demo, let's work on getting this to 100% again. Let's figure out what's going on. One really good way to figure this out is to click this button right here. It's a small button and it's easy to miss. It turns on the inline code coverage display. I'll go ahead and click this and it'll display the code coverage results right in the editor. When that's turned on, I can come down to these highlighted blocks of code and hover the mouse over them. I'm super duper colorblind and can't tell the difference between red and green, but I've asked my wife what these colors are. This red block of code for the argument out of range exception means that it wasn't exercised by the test suite. And if you look at the tooltip for this line of code, it says throw new argument out of range exception was not covered. The if statement itself actually was covered, but not the contents of the if block. To get back to 100% code coverage, I'm going to add a test that addresses the divide by 0 case. I'll copy the existing divide test and then paste, and name this new test divide by 0 throws exception. When you're writing unit tests, you not only need to write tests for the happy path cases in your app, you also need to write sad path or error path tests. When you think about it, so much of the work that goes into writing a solid, resilient, and maintainable application is making sure that you're handling all the places where things can and will and do go wrong. Testing that your application behaves as expected in an error condition is just as important as testing that the core logic works. This test is going to be a little different though, because we know that we're actually trying to cause an exception. The value for value 1 doesn't really matter because the value we actually care about to get into that error checking block is 0. So I'll set value 1 to 6 and value 2 to 0. This test isn't finished yet, but let's try running it anyway. Refresh the test list, click Run All Tests, and then, as expected, we get the exception. The problem is that the test is failing when we need it to succeed. The test as written is kind of wacky. If everything goes as we expect, we won't even get a value back from the divide method. What should we set the expected value to? When you think about it, we don't even need the expected variable. And for that matter, we don't need the actual variable either. Let's remove the expected and actual variables. And then our act and assert phases are going to merge. So I'll change the comment here to say act and assert. And we don't need the assert at all, so I'll remove it entirely. We're getting closer, but if I run the tests again, this divide by 0 test is still going to report a test failure rather than a success. We need a way to call the divide method, but say that we actually expect an exception. To do this, we'll use a method on the assert utility class called throws. Throws takes a generic parameter, which is the expected type of exception you expect should appear. And then it takes an anonymous method where you call your application logic. In this case, calling system under tests divide method. If I'm guessing at how this is implemented, the assert throws method probably just calls that anonymous method as a delegate from within a try-catch block. If it makes it to the end of the try, it fails. If it gets into its catch block, it checks the exception type and eats the exception. Pretty clever when you think about it. Refresh the test and click Run All Tests. And at the end, the tests are all passing. Yay! Now what did this do to our code coverage? Let's rerun the test suite with coverage. The tests run, and now we're back to 100% code coverage, because now we're executing that divide by 0 exception case. Since we have a passing test suite, I'm going to check the changes into Git. And at this point, we're done. We've implemented the add, subtract, multiply, and divide operations on our calculator, and we've got 100% code coverage. In the next part of the demo, I'm going to show you how to use the theory attribute in xUnit to create data-driven tests.